all right, all right, all right. Good evening, everybody. We're getting ready to start the event. Got some nice weather tonight. We doing okay out there? Little? All right, all right, all right.
You can do better than that.
Michael wants more, so we have to give Michael more. Michael gets what Michael wants. How's everybody doing tonight?
We should all
Even
be
better.
excited about the eclipse, right?
Yeah. We got 5 days and counting. Well, less than, depending on what time schedule you're on, I guess. But yeah. So first timers, who's first time coming out to AOT tonight? Awesome, awesome. Good to have you. You're not a first timer. Good to have you. Veterans? You guys know the deal. We got to outdrink the rookies. And so for the first timers, in case you're wondering what AOT is, what we're doing here tonight, I'll let Michael explain. I always forget to introduce the team every time. It's in my head that I know who they are. I'm Aaron. This is Erica. As we know, this is Michael. He gets what he wants. And then we have Brian and Adam running the show. We got Thomas online, making sure the stream's running live. And then Tracy should be walking in at any moment. The legend herself. She'll be here tonight in the flesh.
The return.
And then we got Sam, our trivia master. He's not here tonight, but he's with us in spirit. And with that,
He's preparing for the eclipse like many of us are. And tonight, more than ever, are we plugged in? No. Oh, wait, did I turn it on? No, I didn't turn it on. There we go. What is Astronomy on Tap? As usual, I will remind you that we are a worldwide phenomenon. We have locations across the globe, not just in the U.S. It started just over 10 years ago in Brooklyn, New York. Our very own location started now 7 years ago. This is the 42nd Astronomy on Tap here in San Antonio. So for those of you that have been coming here for a while, we're almost at 50, so that'll be fun. We'll have to do something. But yes, so that is, in a nutshell, as a whole, Astronomy on Tap. Our Astronomy on Tap, especially tonight, is going to be fun. And it's already fun. Everybody has on their tables giveaways, freebie swag, whatever you want to call it, of the punch cards and LRO NASA papers. If anybody wants more of either of those, to either for themselves or to take home, feel free to come grab them during our breaks, because we've got a boatload of both of those. Yes, literally on that order. So we're in the spirit of giving away as we approach the eclipse. This is a unique once-in-a-lifetime opportunity, so we're taking advantage of that. Now, interesting, because we've got two great talks tonight centering on this very eclipse that's coming up. Interactive, you all will get a chance to ask questions. The number is right there on the screen, so we will ask that you text in. Especially, we have a full crowd tonight, so we'll just be doing text, no questions from the audience. So please text your questions when you have them. And a chance to win, as usual. Trivia at the end of the evening. And we've got really cool prizes today. Eclipse-centric. Robert Reeves, as usual, has given us the oh God, what's the name? Lunar Orbiter. Thank you. Lunar Orbiter prints, the 4 of them, so that will be a part of our prizes. But yes, the Eclipse stuff tonight, we're going all in. We're really excited. And beyond tonight, we'll have many great talks in the future, so please follow us on our socials to hear about these events and other cool NASA stuff as they come up. And to tell us about tonight, Erica.
All right, so we have 2 talks tonight, as per usual. The first one will be by our lovely Dr. Angela Speck, our department chair of the University of Texas San Antonio's Physics and Astronomy Department. Then we'll have a short break, and then come back to UTSA Club's, Astronomy Club's Astronomy in the News, given by Caleb Gamar. I will then come back up and tell you guys a couple of quick last eclipse tips so that you are not caught with your pants down on the day of the eclipse, because that's not fun for anybody. And then finally, we will have Cody talking to us about the Indigenous teachings of the eclipse. So, without further ado, Let me get my phone. Apologies, I do not have my reading glasses, so this may go poorly. Named after the iconic Angela Davis, she likes bright colors, is a nerd at heart, and has wanted to be an astronaut since she was 5 years old. Originally from Yorkshire, England, she went to college in London, where she was able to pursue her childhood dreams of majoring in astrophysics. After a brief stint as an R&D tech in a Lancashire company run by crazy New Age hippies, she returned to London and completed a PhD in astronomy. After 17 years as a professor at Mizzou, she is now the chair of the Department of Physics and Astronomy at UTSA. She continues to research and teach astrophysics and to share her passion for all things extraterrestrial. She occasionally misses her home in the UK when she gets cravings for good curry and unadulterated, I don't even know how to say that, cheese. She is also our lead for a lot of our Eclipse stuff, and as such, her life has been maybe a little bit absorbed by the Eclipse, as I'm sure she will love to tell you about.
Okay, so the drinking word is, at the risk of this being really dangerous, eclipse. Okay, so I'm a little wobbly, so bear with me. Okay, so what I'm going to talk about is not just eclipses, but my path through eclipses. And yeah, it's going to get dangerous. But I want to talk about this from the beginning. So let's start with the 70s. Yes, I am that old. So I was born, I was quite a cute baby, during the Apollo era. And I think there's a lot of people of my age who, I was born after the first moon landings, but while we were still landing on the moon. And it was something that had it was just a big thing at the time. And a lot of people of my age were really struck by everything to do with space. Very shortly after that, I obviously developed a proclivity for doing science, although apparently it was hunting dinosaurs as an initial foray. But by the time I was 5, I had decided that I wanted to be an astronaut. Now, there are some downsides to wanting to be an astronaut when you're British, not least that we don't have a space program. But I had decided that I wanted to be an astronaut, and this is like the mid-70s. Now, consequently, my parents, they went to college after me and my sister were born, and when they went to college, I was talking down to their friends, their undergraduate friends, because they weren't doing science. I could talk down to my parents' friends about astronomy, and I did a lot. And so, I was getting all sorts of books, and I was learning all sorts of things. And so the first time I got to witness an eclipse was actually in 1982. This was the very first time there was an eclipse that was available for me to watch. Now, I've put up a graphic up here. I think most of you know how eclipses work now. We can either have a total, where we're actually standing in the shadow of the moon, or we can have an annular, like we had back in October, where the shadow doesn't quite meet the Earth. But we also get eclipses like this, where the shadow doesn't quite hit the Earth, and we only get a partial. So we get a shadow hitting the Earth, but it's only the penumbra, and we only get a partial. And that's what I got to see. This was my first experience of an eclipse. I was 11 years old, and I went to the local park with a black trash bag. And I looked through the black trash bag. Do not do this. But even just seeing this amount of the sun missing had a huge impact. I'd already decided that I wanted to see a total eclipse at some point in my life, but this was the first chance I got. So then let's go on to trying to actually get to stand in the true shadow of the moon. So this is actually showing you all of the eclipses in a 20-year period from 1981 to 2000. So the only totality to hit the United Kingdom in my lifetime is this one right here, okay? 1999. Now, I knew about this basically from, probably about 20 years before I even hit the age of 10. And when you're 9 or 10 years old, you don't think about ever leaving home. It never occurred to me that I wouldn't be still living in the UK. It never occurred to me that I would live anywhere else. And so I had plans from like the 70s onwards to go and see this eclipse right here. But guess what? I didn't get to see it. Because 2 months before this eclipse, I moved to there. So, I moved to the US in 1999, and so I didn't actually get to see that particular lining up of the Sun, Moon, Earth system. So, 1999 was dramatic. Okay, so let's move on and go, well, okay, what's the next chance? When am I going to get to do this? I really, really want to see one of these things. So this is the next 20 years. This is 2001 to 2020. And I don't think I actually said it explicitly. The red lines are where you can see an annular, and the blue lines are where you see totality. And, okay, so I moved to Illinois. I was over here. There was obviously this one, but this was 1999. I'm like, I'm not waiting till 2017. I want to see the next one. And so actually we planned to go and see this eclipse right here. This was 2001, June 21st, 2001. It was in southern Africa, and we're like, okay, this will be great. This was actually going to be, first of all, it's on the solstice. How cool is that? It was going to be in the middle of the day. I'm like, this is going to be really cool. And it was 2 days after my 30th birthday. And I'm like, okay, this is what we're doing for my 30th birthday. Guess what? We decided to get married. That's what I was doing in 2001. And we couldn't afford to do both. And so, and those of you that know my husband are like, what? He looked like that? So I didn't get to see that eclipse either. Okay, so fast forward, and you'll see I've put 2002 down here. So 2002, we moved to Missouri. Me and my husband take jobs at the University of Missouri as faculty. And I arrived there in 2002. And some of you may already know this, but there's an interesting relationship between astronomy faculty and amateur astronomers. And the amateur astronomers meet me, and we're just talking. They're like, so, there's this eclipse coming. You've got to be ready for this eclipse. This was 15 years before the eclipse. So, 2002, I'm already starting to think about, okay, this is the next thing that's coming. Cool, okay, we're going to get ready for this. So we start planning. But there's a couple of things that happen along the way. So let's talk about 2012. So in 2012, I actually drove, so we were living in Missouri, right about there. I drove my kids down here to see this annular. So this is the last time there was an annular eclipse prior to the one that just happened, okay? And this was my first chance to see that ring of fire, okay? And so I drove down here. Now, this was in May of 2012. I don't know how many of you remember 2012, but it was a weird year from an astronomical point of view. 2 weeks after this, we had the transit of Venus. So we were not only doing, going and seeing this amazing ring of fire eclipse, then we did an event for the transit of Venus, and then 6 months later, the world is going to end. And so we're all talking about Mayans and why we really don't need to panic about those things. So that was 2012, and it was really starting to build up towards the 2017 eclipse. Oh, yeah, sorry. Nice picture of an annular. Okay. And then all hell broke loose. So, 2014, I'm on the American Astronomical Society's council. And at this time, I've been pushing them to start doing things about eclipses. And so they put together a task force. And guess who they asked to chair it? And so I was planning for the entire nation from 2014 to 2017 and planning locally. And during that time, I was doing so many different things, and it was just like it completely took over my life. So this is actually literally me on C-SPAN twice. Who goes on C-SPAN? I did a TEDx talk, I did school trips, I did everything. In fact, I'm going to show you this. This is actually talking about all the different places that I was just interacting with people to get them excited about the eclipse. And it ranged from, libraries to doing things in national parks, doing things in pubs, being at festivals and all sorts of things. And this was all the time. In fact, in 2017 itself, between January 1st and August 31st, I did 300 presentations. Yeah, eclipses really did take over my life. But I also had a beer named after me. So, you can have some fun with this. Okay, so fast forward to 2017. And for those of you that have never seen, actually, let's stop. How many of you have seen a total solar eclipse? So some of you have. This is really what it looked like. So this picture was taken by my friend Rick up in Oregon. I was in Missouri. It looked exactly the same. You really can see this beautiful white fluffy stuff, but you really can see these little pink bits. And this picture down here, I was actually broadcasting live on the local ABC station, talking through the eclipse. And from a rooftop bar, because why not? I mean, so this was 2017, and it was just like, by the time we got to the end, I was exhausted, but it was fantastic. And rather than actually sating my desire to be in the shadow of the moon, it just made me want more. So now I'm looking at the map again and going, well, where do I go next? What's my next chance? Well, the next chance was 2019. It's this one right here. And me and my mom actually went all the way to Argentina, and we're somewhere right about there. And so this is just kind of showing you a little pic. So you're watching it more or less setting over the Andes. This is literally a picture I took with my iPhone. So that's just, and this is 5 years old. This is an older generation. You can actually get a pretty decent picture with an iPhone. So that was 2019. I returned from that trip to Argentina and moved to San Antonio 3 days later. So again, definitely took over my life. Okay, so what's next? Well, I'm not done yet. I'm like, okay, what's the next opportunity? So 2023, the last total solar eclipse anywhere on the planet was a year ago. And it's this little line, little skinny line here. And I was right where there's a tiny little bit of Australia right there. That's where I was. Now, to be fair, I didn't pay to go. In fact, I was being paid to be there, which honestly is the sweetest side gig ever. But, that's where I was. So I took some time off and went to Australia last year to see that eclipse. And that eclipse looked like this. Now, the reason I want to show this is You know, the sun has this activity cycle, so this eclipse is much more like what we should expect in a few days' time, okay? What you're seeing here is, this is a completely different shape. It's like the white stuff is going in all directions. You can also see these pink bits. They're a little bit brighter and bigger. This is what we expect because the sun is more active now than it was in 2017. So people are actually putting out predictions of what they think the eclipse is going to look like next week. This is more or less what you should expect to see. So let's talk a little bit about what's coming. And yes, it has taken over my life again. If it hadn't, I wouldn't be here right now. This is showing you where the path of totality is. Basically, the whole of the US, except for a little bit of Alaska, gets to see a partial eclipse. But where we are right now, will not see totality, and I'm going to emphasize that in just a second. So here is the edge of the path of totality. So you've got this narrow line where you can see totality. And I really want to stress this. Where we are right now, we are not on the path of totality. You want to get over here, okay? And people are looking at this and saying, but it's 99.9%. It's 99.9% of the sun is missing. It's going to be great. No, it's not. It's going to suck and you're going to be really disappointed. I want to make this clear. The sun is about 1 million times brighter than the full moon. What that means is that when you have blocked out 99.9% of the sun, you have 0.1% still showing. That's 1,000th. That's 1,000 times more light than the full moon. And that means it doesn't get dark and you don't see the corona or witness all the things. So even at 99.9%, you do not want to be there. Please somebody tell the Alamo, because they're having a party. But for the rest of you, if you live or work in this part of town, get over there just for that bit of the day, okay? And this was an XKCD cartoon that came out this week, and it is just exactly right. Now, what I want to end with is I just want to talk about, and I don't have a graphic for this, I'm just going to talk through it. I want to talk about what the total solar eclipse experience is. So we're going to start at the beginning of the eclipse. We have first contact. The moon is just moving in front of the sun, and if you weren't paying attention, you wouldn't notice a thing. Until we get to about 75% eclipsed, you don't notice. Your eyes adjust, your pupils get bigger, you don't notice it getting darker. Once you get to about 75% eclipsed, now you'll start to notice that the sky's the wrong color. You might not know why if you didn't know it was an eclipse, but you would be like, okay, the sky is like this weird color now. Animals start to react at that point. But then it's still not that dark. Those of you that witnessed the annular eclipse will know it did not get that dark. Until we get to about a minute out, at about 1 minute out, the sky is like an overcast day. And over the next minute, it's going to drop from overcast day to full moon dark in 1 minute. And in that minute, you're going to take in Bailey's beads. This is where it looks like there's beads of sunlight on the surface of the moon. This is where there are valleys and mountains on the moon. You are literally seeing the topography of the moon as the sunlight can get through the valleys. The very last thing before you are plunged into darkness is the last valley is letting in light, and it should, oh no, that one. It should look something like this. And what you're seeing here is we're finally blocking out enough we can start to see the sun's atmosphere, the corona, but you are seeing just a little bit of sunlight still coming through. This lasts for about 2 seconds, and then you are plunged into darkness. And what you can see is there is a hole in the sky where the moon is. There's this big wispy thing around it. There's pink bits coming off it. There's stars, there's planets. But wait, hang on a second. It just got cold because we blocked out the sun. And that change in temperature means that there's breezes. So you get goosebumps, and not just because it looks awesome. At the same time, you listen to the noises. If you're not around other people, the birds stop singing, the bees stop buzzing. If you're around other people, there will be screaming. There always is. The other thing that you need to look out for is the horizon. The sun is going to be up here. It's going to be really high. It's going to look like a black hole. Around it, you've got the corona. Around it, it's still darkish. But as you move your eyes down to the horizon, in any direction, it's going to get lighter until on the horizon, all 360 degrees is sunset colors. Depending on where you are, you might have anything from a few seconds to a few minutes, and you have to take in all of the things I just said. This is not like anything you have ever experienced, so make the most of it. And I will end by showing you what planets you can see. Thank you.
Well, thank you very much. That was amazing, and I'm so excited. And I love your shirt, by the way. That's perfect. All right, as a reminder, please send in your questions to our text line on the television. Let's see. Our first question, this one's interesting. Can you stand on the line, the edge of the totality path, and see partial light and darkness if you...
Oh. No. So the edge is a little bit tricky. In fact, there was a map that just came out that says the maps that most people are using is probably not quite right. So exactly where the line goes depends on not only having an accurate map of the surface of the moon, but also the size of the sun. And depending on the assumptions you make about the size of the sun, it changes the position slightly. So there's a new map that basically says it could be a few hundred feet further towards downtown San Antonio. It's only a few hundred feet, but that makes it tricky. Even back in 1920s, there was an eclipse over Manhattan where they had people sitting on the roofs of different blocks, and they had people recording whether they saw it so they could try and figure out where the edge was. The edge is a little bit tricky.
Interesting, thank you. This one, I guess that, yeah, it's a concern. The elephant in the room is the weather. What to make of? What can we do?
Okay. Nothing. Okay, so there's a couple of different things here. First of all, there are lots of weather models, and it was really interesting. There's actually the National Weather Service is doing briefings every day, talking about what to expect. And they were, reasonably confident. And then a cold front came through, and they were like, wait, it suddenly, like the storms we had over the weekend, and they were like, oh, well, now we're not so sure what it's going to be like. So even right now, it's not clear that we know what it's going to be like. Even for the annular, 3 or 4 days out, it looked like it was going to be cloudy in Albuquerque, but it wasn't, because that was the prime spot for the annular. And so at the moment it's iffy, but I'm not going to get upset. Now remember, it's still going to get dark. It's still going to get really dark. So even if it's cloudy, it's worth going out. The other thing is that if the cloud is not super heavy, so if it's just cirrus, don't worry about it. If it's like cumulus clouds, but not really heavy clouds, they can actually get cleared out by by the shadow of the moon moving in. Because you change the air pressure and the breezes, it can actually clear out. So worst case scenario is it just gets dark. Still kind of cool. Best case scenario is we have a nice clear day.
Thank you. Mercury is dark here. Will it be visible or no? Will you be able to see Mercury in all its retrograde glory during totality?
Well, to answer the specific wording of the question, you won't see it moving. So, no, if it gets really dark, you might be able to see it, but I don't think it's going to get that dark. So basically, we're definitely going to get to see Jupiter and Venus. They're the brightest planets, right? But it depends on how dark it gets, and how dark it gets depends on the ambient conditions. If you've got little bits of light cloud, you get more light scattering, it won't be as dark. If it gets dark enough, we might see Saturn and Mars. We will not see Neptune or Uranus. You cannot see them naked eye. I mean, if you've got a telescope, you might be okay. And it's unlikely that Mercury will be visible. The other thing that might be visible, but that's not clear yet, is right about here is where there will be a comet. It will be there. Whether we can see it or not depends on how dark it gets.
Very interesting. Thank you. When are you leaving UTSA for the next university in the path of totality?
So, the next eclipse in the US, assuming I was to not leave the US, the next eclipse is in 20 years, and I hope I've retired by then. However, there are 5 eclipses over Australia in the 30s. So I'm kind of hoping there's an Australian university wants to hire me. That would be great.
Very interesting. Thank you. Sure. We'll.
What's the pink stuff in the kind of corona?
Sorry, oh, okay. So the question was, what is the pink stuff? It's the same color as my hair. Basically, so I want you to think about, if you've ever seen pictures of the sun, where you see these big loops of gas coming off the surface of the sun. And, you know, most people think of that as being yellow or orange because that's how they're presented in pictures, because we think of the sun as being yellowish. But they're not. They are pink. And it has to do with the way the sun behaves, like the main part of the sun. Even though it's made of gas, it behaves more like a dense thing. And so its color depends on its temperature. But at the surface, the density is really low, so that gas is behaving kind of like gas in a neon tube, except it's not neon, it's hydrogen. And when you put hydrogen into a neon tube, what you get is something that looks like Barbie pink. So it really is these pink loops that are coming off, and that you can actually see without any help whatsoever.
All right. Thank you for that, and that's it for the questions. Let's thank our speaker once again, Dr. Angela Speck. Thank you. Another fun XKCD question. There we go. All right, break time. We're on a 10-minute break. We'll start now. Please order. Do not crowd the bar, first of all, and then we all are excited about the eclipse, and we all need eye protection, glasses. We have glasses now. We still have some that we can give away, but we also. All of us up here happen to be officers of the Graduate Society of Physics students at UTSA, and we are doing a fundraiser selling glasses at $3 a pop or a 2 for $5 special. So if people would like to come get glasses, feel free to come right up. Huh?
And libraries. If you want more free ones at libraries.
Oh, yeah. Libraries will have them too. Public libraries. And then, yeah, our merch table's up here, so feel free to look at our merch table. And then we also have some demos, the punch cards, like I mentioned. So we'll be right back. All right, 7:45.
Someone really needs to. astronomy journalist in the house, Caleb Gamari, is going to give you the highlights of the last month. Take it away, Caleb.
There we go. Okay. All right. Well, good evening, everyone. And here is this month's edition of Astronomy News. So here we go. First and foremost, what will be up in the skies this coming month if you go outside? Well, one, we are now in the springtime season, so you have almost a perfect springtime sky. All of that wintertime stuff is setting over on the western horizon. Jupiter is still there in the sky, but it will be a sight in the early evening sky, and it will get lower and lower as the month goes on. So do bear that in mind. Nonetheless, though, all of these constellations that we associate with the springtime season, Ursa Major, better known by the asterism as the Big Dipper, the constellation of Boötes, which contains the bright star Arcturus, the constellation Leo, right there, indeed, are starting to make their way up in the springtime sky. Now, I will say, the bad thing about the springtime season is that in this journey that we make across the sun throughout the year, that happens to be the point in the year at which we are looking out of the plane of our galaxy into distant intergalactic space. The awesome thing about that is you get to see many very nice distant galaxies during that time of the year. The bad thing about that is most of these objects are actually fairly dim, so you do not get a lot of the really nice close star clusters and star-forming nebulae like you do during the wintertime season. Nonetheless, so there are a few objects that you can see with binoculars if you are under a very dark sky. The first one I will point out to you is this one right here. It is a globular star cluster, as imaged here, called M3. This is a group of very, very old stars clustered extremely close together. It is a group of stars that orbits the core of our galaxy in an area that we call the galactic halo. It's somewhere in the neighborhood of about 36,000 light years away. So you're looking at it as it appeared about 36,000 years ago. Through a pair of binoculars, what you will see when you look at this is a little fuzzy spot. So follow the arc of the Dipper to Arcturus, and along that line, just look with the pair of binoculars. Again, very dark sky, and you will find M3 there in the sky. Now, Dr. Speck spoke a little bit about this, but I figured I'd highlight it here. I did not know that was going to be mentioned, but nonetheless, it's worth going over again. What you will be able to see at totality during the eclipse. Now, I'm going to very much emphasize that if you have never watched a total solar eclipse before, and especially if you are in an area where there's only, about a minute or two to actually see totality, don't waste a lot of time with a pair of binoculars trying to look around for some of the fainter things that are incidental to the eclipse. Focus on the eclipse primarily. If, however, you are a more seasoned observer, and if you are in one of these areas where you get the full 4.5 minutes of totality, take a look around the sun at the time of totality. You will be able to see all of the visible planets that you can generally see with the unaided sky in the nighttime sky all in a row there. You will find Mars and Saturn if you're going from right to left. Venus will appear most predominantly. In fact, you won't have to do a lot of looking around for it. It is very, very bright. Then on the other side, if you go toward the left-hand side now, Mercury shows up right there. Now that one may be a little bit of a challenge. I was able to see it in the evening sky just a few nights ago. I went out and took a look at the area around there. I was actually looking for the comet Pons Brooks. More about that in a moment. Mercury was fairly easily visible at that point. But again, You're in a little different situation here. Mercury is finding its way back toward the sun, at least in the angle we're looking at in the sky, so it will be just a little more difficult to find. And then Jupiter is another one much like Venus. It'll stick out like a sore thumb. You'll be able to see it quite easily. But in between Mercury and Jupiter, probably about a quarter of the way closer to Jupiter there, you'll probably be able to see, if you have a pair of binoculars, a little fuzzy line of light. And that is the comet Pons-Brooks. It is actually visible in the evening sky right now. You have to have a good clear horizon. I did go out and take a look at it a few nights ago. It is very easy to find. I was just using a small 90-millimeter telescope. It is likely visible with binoculars in a very dark sky, but nonetheless, if you're up for the observing challenge, see if you can find comet Pons-Brooks there during the eclipse. So now for the news segment of this. First off, a really interesting discovery using the James Webb Space Telescope. So over here you have a very famous Hubble Space Telescope image of the galaxy M82. M82 is a very active galaxy. It's actually visible pretty easily through binoculars in a good dark sky. It's just off the pan of the Big Dipper in the sky. Take a look. Maybe that'll be something I feature in next month's Astronomy News edition. But nonetheless, this galaxy is extremely active in terms of star formation. It's what we call one of these starburst galaxies. And in these starburst galaxies, there are these very intense intergalactic winds, as we call them. And the Webb Space Telescope was able to observe in the infrared the emissions from hydrocarbon dust grains, actually. And through those observations, you can actually see the direction and the general geometry of these winds in this galaxy. Very, very fascinating series of observations. Now, a good citizen science story here. So there's a really great spacecraft called SOHO, Solar Observatory for sheesh, mixed up on that acronym. Anyway, nonetheless, so this observatory is extremely useful for understanding space weather, understanding the solar wind, the structure of the outermost corona. We, of course, can only see it at innermost during the time of a solar eclipse, but like what we're going to have next week. But nonetheless, though, this satellite is very adept at being able to see the outer corona. And there's a citizen science project that allows people to go through the images from this satellite and be able to see comets as they pass around the sun through the imagery here. And they've actually discovered 5,000 comets in this project. The most recent discovery, the 5,000th one discovered, was accomplished by Han Zhetan, originally of China. He is now working on his PhD in physics in Prague in the Czech Republic. And he's been on this project since he was 13 years old, looking for these comets. So again, a major accomplishment for citizen science. Definitely, for many of you out there, go and look for these kinds of projects you can latch on to and be able to contribute to some really amazing scientific discoveries. So how many of you remember a number of years back when there was that big announcement about imaging the event horizon of a black hole for the first time? Yeah, all right, many of you remember that. Okay, so fast forward a few years, not only do we have the imagery of the black hole at the core of M87, we also have imagery of the black hole at the core of our own galaxy. And fast forward even more to now, we are able to map the magnetic fields around these black holes using a method called polarimetry. So the radio region data used to construct these event horizon images, part of the Event Horizon Telescope Consortium project as a whole, is actually able to be used in such a way that you can see the polarization of the radio emissions from these event horizon regions. And using that polarization of that radio light, you can get an idea of the magnetic fields that are present there. So this is a mapping of the direction of the magnetic fields near the event horizon, of course, of the black hole at the core of our galaxy. really, really fascinating work here, and really great imagery as well to go along with it. One more discovery, and this one actually concerns another one of these starburst galaxies, again, one of these very active star-forming galaxies. The Sculptor Galaxy, as it's called, NGC 253, great fall-time object, but you'll have to wait a while to see it again because obviously we are out of fall. But nonetheless, though, using data from the Atacama Large Millimeter Array, there was able to be a mapping of the radio emissions corresponding to many different molecules, about 44 molecular species, some of them actually more complex carbon compounds. And this series of images here, this series of images here actually shows some of the radio wave emissions associated with these chemicals. And this actually gives a great opportunity to correlate the presence of these chemicals with stages of star formation. Machine learning algorithms have been applied to this data to understand the presence of certain chemical compounds in different regions associated in this galaxy with different stages of star formation therein. So really fascinating work here. Finally, just a couple of images to leave you with. These are things that happen to just really amaze me as I was going through looking for the stories to cover this evening. This image here is of the Vela supernova remnant. It is from what right now is one of the largest digital cameras attached to a telescope. It's what's called the Dark Energy Survey Telescope, Dark Energy Survey Camera. It's a 1.3 gigapixel array. Really, really high resolution camera. And not only do you get the larger image here, but you can zoom in and see various features there. I encourage you to look up this image. Just look up Dark Energy Survey Camera, Vela supernova remnant, and of course Vela pulsar within, and you'll bring up this image. The European Space Agency's Mars Express orbiter just celebrated 25,000 orbits around Mars. And this is the image they released to commemorate that achievement. It is of the Tharsis Plateau region on the planet Mars with that extremely large dormant volcano, Olympus Mons. Few things not to miss. Tomorrow evening at UTSA, do not miss this. We have a public talk by Nobel laureate and former head scientist for the James Webb Space Telescope project, John Mather. He will be speaking tomorrow at 7:30, main lecture building on campus, main building lecture hall on campus. So, you know, be there, be square. And we will have star observing after this event in the field that's next to this building. So indeed, mark your calendars for this, clear your evening. It's going to be a really fantastic time. I personally had the chance to listen to Dr. Mather speak before. Really fascinating man to listen to. Again, make time for it. It's really going to be awesome. Friday night Celestial Lights, that is the next observing event that we have at the UTSA Observatory on April 12th. Again, do not miss. This one has a lecture beforehand and then the observing. We do not have the first Friday observing as usual this Friday because we're already doing the observing for the Mather event and we're pretty booked up on other observing events over the next few days due to the eclipse coming up. And then observing at South Llano River State Park. That will be on April 13th. And cross out that March 9th thing. Oops. Cross out that March 9th thing there. That's a remnant from an old slide. So yeah, April 13th is when we will be out there next doing observing. Around sunset, find your way out there. It'll be a great time. So that concludes Astronomy News. Thank you very much. And I'll go ahead and hand the microphone to Erica, and she will tell you more about some things to keep in mind on observing the eclipse. So here you go.
Thank you. All right. Welcome to Last Minute Eclipse Tips with me, Erica Dykes. Lovely XKCD comic that popped up on our Discord earlier this week. That felt very appropriate considering we're all looking at the weather forecast and crying a little inside. So let's get started. So you already saw this one, courtesy of Dr. Speck, who looks like she's already left, but that's okay. If you are not in the path of totality, you will not get to see a total eclipse. Do not think that 99% coverage of the sun will give you 99% of the total eclipse experience. It will not. Be in the path, or you're not seeing words I can't say because it's a public event. So, one really easy way to go and check where you can potentially be in the path is this lovely app that is recommended by the American Astronomical Society. It's called Totality by Big Kid Science. It is available on both the Android and Apple app stores. I use it personally. It is really, really helpful. It's powered by Google Maps, and you can zoom into a location, pick it, and it will give you partial eclipse start time, the actual eclipse start time, like all of that fun details. It will give you, if you're outside the path, your coverage amount, all that fun stuff that you need to plan whether you're actually going to be able to see the eclipse and how long you will be able to see it, all of that fun jazz. Me make sure. Oh, yes. Also, please, 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 please check that your location is actually open to the public. UTSA is not. Do not come to UTSA. We do not have the parking. And if you're the reason that somebody misses a test, they're going to be really, really, really mad at you. So please don't. So keep that in mind. If you are a UTSA student, though, we do have an on-campus event. It's just not open to the public. Cool? Cool. So another thing shared by our lovely Tracy Becker earlier this week as well is a couple of public events that are happening on the west and northwest sides of town. You can see a list here, and then this is the Google Map link that somebody created to show all of them, various parks and community centers, and then Six Flags will also be having an event of some form as well. Hopefully they choose not to set off fireworks during that time. Dr. Speck already yelled at him about it, so. If you are going to get glasses, please do it now. Do not wait until the weekend or the day of. You're going to struggle to find them potentially. Some larger retailers may, like H-E-B, et cetera, but be careful. One thing to know, do not get them off Amazon, please. There's no guarantee that what you are going to get off Amazon and other similar online retailers are actually real glasses. They may not actually be solar safe. If you are not sure, the best thing to look for is this ISO certification here, and there's a specific ISO filter that they must comply with, which is this lovely number here, 12312-2. There are fakes out there that do actually have that certification, so when in doubt, check the AAS Eclipse Task Force recommended or known suppliers and manufacturers. If the name of the manufacturer or distributor is not on that list, better safe than sorry, don't trust it, okay? If you're going to travel, and by travel I mean going more than about 30 minutes down the road, keep in mind we are going to experience heavier traffic than you see during rush hour, and I mean way, way, way heavier. Places out in the hill country are expecting 2 to 3 times their own population to be in those areas during the eclipse. And during 2017 eclipse, travel that normally took 4 or 5 hours took upwards of 12 in some places. Keep that in mind. If you're going to go out into the hill country, be prepared to be there all day. Or better yet, make sure you already have accommodations, which good luck getting anything at this point. Just to know. Other thing, if you're going to be out in the hill country or any place that you are not super familiar with, print directions. You may be there longer than you anticipate. Your phone may die. If you still use a separate GPS, that may die too. Self-service may go out. We don't know. So just, again, better safe than sorry. Print your directions if you're going somewhere that you're not super familiar with. Come on. On the day of the eclipse itself, make sure you have somebody, if you are not at a public event where they will be calling times, that knows what time totality starts and ends very precisely at your location. And I'm talking within the minute. Because what's going to happen is, like Dr. Speck said, it's going to get really dark and your eyeballs, your pupils are going to dilate. And if you are not careful and you take your glasses off too soon or don't put them back on fast enough, you can hurt your eyes. So be careful. Make sure you're watching the time. There is an app that was recommended to me, but I have not personally used, called Solar Eclipse Timer. It does cost $1.99 to get this particular eclipse, but the purpose of the app is to call time for you. So if you are not at a public event where they're going to be doing it, then this is one potential way that you can try it, or somebody in your group can watch the time itself if they've already seen an eclipse. Just be careful. Make sure you know when things start and stop. That also said, the only time that you can take your glasses off safely during a total solar eclipse is during totality. Any other time, you are going to be risking your lovely little eyeballs, and they may or may not be fixable. So please be careful. You only have one set of those. I don't think we figured out eye transplants yet. So let's hope that on the day of, we get this lovely view that, again, was taken by Rick Feinberg up in, Oregon, in the 2017 eclipse. That we don't get this, and if we do, right before we get clearing like we did during the annular. So if you have any questions, please feel free. I'm going to be around until well after trivia, helping to pack up everything. So happy to answer any questions.
All right, thank you, Erica. That was very informative. Yes, please all, follow, that advice. It's going to be a hectic day. It's going to be fun, but yeah, there's going to be a lot of people here, especially if you're like myself and going out into hill country. It's a lot of two-lane roads that doesn't fit a lot of cars, and there's always that one slowpoke. I digress. All right, our final speaker of the night, I'm doing two things at once, is Mr. Cody Cly. Cody is a proud Diné physicist. Trivia time. Favorite time of the night, yes. All right, yeah, so we'll go on a little 5-ish minute break. If you have to go, thank you for coming. Please make sure that, please make sure that you tip your service well. They're doing a fantastic job with us tonight. It was a full crowd. This was an amazing crowd tonight. I'm really so happy that everybody's so excited about the eclipse. Maximum group size, 4. Please write only the letter for multiple choice questions. I'll remind you about that. No cell phones allowed. We'll come around with sheets and pencils. And please, if you have a need for any merchandise, glasses, punch cards, the LRO lithograph, come find us. We've got you covered.
I'll give it a few minutes and then go around.
As a reminder, we have a maximum group size of 4. Please only put down the letter choice for the question, because it makes it easier for us to grade, and the quicker we can do this all. And no cell phones. Let's keep it fair, because we've got some great prizes tonight. So as mentioned, we have Robert Reeves's Lunar Orbiter Prince as the first prize. All 3 categories are getting something eclipse themed. So for example, we have these cool posters. The first and second place prize will be getting one of these. They're really, really cool art. So really excited. There's this tumbler, Eclipse tumbler, second place prize, and then Eclipse books by Jeffrey Bennett for the third place prize. Glasses.
No glasses. You gotta buy
come
them.
find us if you grease my palm. No. If you know a guy. All right. Without further ado.
Odds. All right, first question. The Easter celebration does not occur on the same Sunday each year because it depends on the lunar cycle. During which phase of the moon does Easter always occur? Is it A, the first quarter moon, B, the waxing gibbous, C, the full moon, D, the waning gibbous, or E, the new moon? Some of you on TikTok may know a little something about this.
Of course,
Does everyone know, like wax on, wane off? No? Just me? It's whatever. Yeah. Wax on is when it's approaching, wane off is when it's receding. It's whatever. You learned something, I guess. I don't know. Yeah. Every full moon or like gibbous, I'm like, wait, wax on, wane off. It's waning. Yeah, I got it.
All right. How's everybody doing on this one? Can we move on? All right. Question 2. Hello? Okay. Hybrid eclipses. In the Sun, Earth, Moon system, the rarest eclipse is called a hybrid eclipse, a phenomenon where A, there is a solar eclipse during the day and a lunar eclipse that night. B, the sun passes between the moon and the earth. I gotta put on my bathing suit. C, during a total solar eclipse, the International Space Station transits the moon, okay? D, the rising setting sun is undergoing a total solar eclipse. Or E, annular, I keep saying annular solar eclipse evolves into a total solar eclipse. Those are your 5 options. Only a few make sense, so please.
There's also F if the sun has to call in on Zoom, but that's whatever.
I'm a little bit, Sam, if you're watching, I'm a little bit shocked that you didn't put that the Eclipse has more fuel efficiency. What? I forgot my cheesy joke today was that you all are getting free punch, just not the good kind. I'll be here all.
Everybody good? All right, question 3. The largest 7-pointed star on the Australian flag represents its different states. However, given its location relative to the Southern Cross, it sometimes gets mistaken for which star. Is it A, Antares, B, Hydra, C, Gamma Crux, or D, Beta Centauri? Or no?
It's all G. It's all G.
Yeah.
Hydra.
All right, everybody good?
Moving on. Question 4. Periodic trivia. Which element on the periodic table has the abbreviated symbol SN? Is it A, starium, B, scandium, C, tin, D, antimony, or E, helium-3? If Sam were here, he'd be on the floor right now. Bonus, so this one I want you to write next to the answer on that same line, please. If you discovered an element, what would you name it? And the most creative response will be given multiple points. Be creative. I'll riff on some fun elemental names while you guys think. Let's see. There's the name ones like Einsteinium, Californium. No, that's a state.
No, what? California. Yeah. California.
There was MIN?
No, it's an element. California.
No. That's what I'm saying. It's
yeah.
it's
I
not.
see what you're
Yeah. No, it's people, states. Isn't there a borium? Yeah.
There's an element that was named after a planet soon after it was discovered, I think. I can't remember. But then following that tradition, they named plutonium after Pluto a couple days, because they discovered plutonium not too long after they discovered Pluto. Plutonium is no longer an element. You heard it here first.
The IAU has downgraded plutonium to a dwarf element. You heard it.
All right, everybody good on this question?
All right.
You got your crazy answer? All right, question 5. When was the last time a total solar eclipse passed over Texas? Is it A, is this the first time it's ever happened? Is it B, 1878, C, 1940, D, 1994, or E, just last year? I guess I must have been asleep. I don't know.
News to me.
Huh? It could happen. Grad school is a wild ride.
This one's RTFQ, because it says total.
Oh, yeah. Where are you going to be?
What?
Where are you going to be?
Is this 1604?
No. Oh, is it? No, I don't think so. No, it's not.
Yeah, no, it has to be.
No, it's not. That's 1604.
Oh, yeah, you're right.
I don't know what road that is. I don't know what road goes around us.
But I'm assuming that's Bernie.
Yeah.
Okay.
About there.
So somewhere there. Because this is the one that big one that cuts through Fredericksburg.
Yeah.
And then this is Johnson City.
Yeah.
So yeah, I'm gonna be somewhere there.
I'm gonna be like, I think like right there. Maybe in Marble Falls. Yeah, he's not putting me in Bandera. He put me in Marble Falls.
Interesting.
It's a really pretty place. It like overlooks the lake. It's really nice.
Send pictures. Send pictures. Right, question 6. SpaceX supremacy. SpaceX's Starship has only launched from Boca Chica down in South Padre Island, but a new launch site is being built at what other facility? Is it A, Area 51, for secret reasons, B, Vandenberg Air Force Base, I believe, C, Van Horn, right here in Texas, or D, Cape Canaveral?
Just right on top. Private companies moving in, I guess.
Just build another one.
All right, everybody's got their guess. Bonus question time.
Bonus.
All right. This one, it's a doozy.
Supposedly.
Just bear with me. There are 25 horses. You can race up to 5 horses to find out their relative speed. What is the minimum number of races necessary to determine the 3 fastest horses? You do not have a stopwatch or an iPhone or anything that can measure time. You can only race the horses 5 at a time. How do you know which ones are the 3 fastest?
Supposedly, it is a Google interview question. Like if you're interviewing for a job at Google, it's meant to be one of those figure out how your thought process works.
And we are merely the announcers. If you have problems, take it up with Sam.
If you have a problem, next time you see Sam Hart,
That's why Sam's not here.
yeah.
Yeah. That's a you question. No, I'm asking you. I am me. Who are you? Yes, I am you, but who are you? But I am me. No, I am me. Who are you?
I will say, if we want to turn it spacey, we just change the horses to be spaceships. And there you go.
I've watched the videos, and I still don't get it. It's a complicated algorithm.
It makes sense. Once Sam explained it to me, it made sense on how you do it. And I can see why they asked that. Because when you're doing it,
Yeah.
computing, you have to think of the most efficient way.
All right. The moon question is the full moon. We've all disagreed with him because we know when the
When
full
you
moon is.
have,
Well, he added it in
well,
your
actually,
question,
does
so
anybody need a question repeated?
And that he's the right one, but I know he's not.
Okay. Yes, when you are done with the question, with your trivia, bring them up and do not forget your writing utensil. If you need us to return to a question, speak now.
Number one. We have number one. We got number two. We got three. Number 1,
Sold.
2, and 3. Way to go up.
When does Easter occur?
Here's question 1.
I am right.
Wait. Go back to wait. Oh no. Yeah, you're fine. No, we're just repeating questions. And then number 2, please. Yes, when the sun has to take a Zoom call.
All right, besides 1 or 2, does anybody need another question that they want to return to? What?
That was just for you.
All right, so yeah, once you bring them up, don't forget your writing utensil, and we will grade them. We will go over the answers, and we will divvy up prizes, and we will do our closing remarks for the evening.
Thank you.
Nice. Yes.
Oh, they had it right.
Which one's creative?
Oh, that's pandering.
Yeah.
That is pandering. He'll get 1 point. Jacobian.
I put this on backwards,
Oh my god. Jacobian, not to be confused with your Jacobian. J is not on the periodic table. That one.
Dumb and dumb you. I like that one. 2.
Oh wait,
Speck 2020.
of course, the undergrads do it again. People aren't doing so well.
Did everybody bring up their sheets? We have everyone's? All right.
They got the bonus right.
I had a few that got the bonus. Five not here. Cornell. Okay, that's they win.
So now we have to decide amongst the 4 who gets third.
Speck winning to me.
She was right. So none of the fours got the bonus right. So then
We should pick the
there's Eclipse, topical, Speck winning 10 members. I like that. It's clever. I can't read that. And Millennium.
of the fours. Well, who got closest with the bonus? Let's go with that first. They did. So I think they should get third, but who had the most creative?
Honorable mention.
Bill Nye the Science Guy. I like that one. It's a cute line. If you don't know, Baron.
Yeah, it was a guy who was like, most important thing, you never see.
Okay, everyone, we are ready to reveal the answers for tonight. All right, question 1, which was about the moon phase on Easter,
Yes.
is...
The answer is waning gibbous. Wait, but does anyone know when Easter happens? Lower your hand, Caleb. I know you know. I know you know. All right, we got 2 people who know when Easter happens. Now, correct me if I'm wrong, Caleb. Bingo! There we go. No, it's the first Sunday after the first full moon in April.
No, after the spring equinox.
After the spring equinox. So the first Sunday after the first full moon after the spring equinox. So it would be waning gibbous because it's after the full moon. Yeah, it would have to be within 7 days.
All right. Yay, science.
Oh, but that's because they used to use a lunar calendar. That's why.
Yes. Yes. All right, question 2, hybrid eclipses. What is a hybrid eclipse? No, the sun is not between the moon and the earth.
No, the sun calls in for a Zoom call.
The answer
It's obvious.
Really is E, an annular solar eclipse that evolves into a total solar eclipse. So,
Wait, hold on.
So, the moon is in the sweet spot of being just far enough away that it doesn't cover the sun. But as it's going through the eclipse, it does enter the zone of covering the sun, and you get a total. So,
Whoa, hold on. That means the moon, while it's happening, is getting closer to Earth such that it takes over the sun.
That's what I said!
yeah.
How does that even happen?
It doesn't happen often. If you look at the maps, I don't know if anybody noticed this, but when Dr. Speck showed her maps, there was 3 colors. There was the blue for total, the red for annular, and the pink for hybrid. There were not a lot of pink lines on that graph. It's rare. It doesn't happen often, but it does happen.
That would have to be only on the poles. It has to.
No. Look at a map. Look at a map. Look at a map. All right. Question 3, which was on. It was the question about something. The Australian flag.
Oh, okay. Yeah.
So yes, if you look at the map down there on the left, there's the Southern Cross or crux, and so the 4 stars are these 4 stars here. There's that bright one right there. That's that one, and then if you go all the way out here to Beta Centauri, it's this bright one, and that's what's represented on the flag of Australia. Today you learned. Some of you got it right, though. Some of you knew it. All right, the next question, which was on the SN element. What is the SN element? And the answer is tin. The answer was tin.
It's a Latin.
Antimony, which is up there, is SB. SB. So that was a tricky one.
Starium's not real.
Scandium, I think, is. Oh, really? Interesting. And helium-3 is helium-3. I don't know what to say about that one.
The most.
We'll get to the bone.
Michael wants to.
We'll do it in the thing.
Question 5 was about something. 1878.
The last eclipse ever took.
Glad to know it was not last year.
And it's interesting because, what they're doing is not going to be much different from what we're doing on Monday, sitting around with our fancy telescopes looking up. There'll be more people. More people are involved. I'm trying. All right, the final question was about the SpaceX launch site. So we have Boca Chica down in South Padre Island. That one's been ongoing for a while now. The new one will be, for Starship, at D. Cape Canaveral, which is fitting because, and I may be biased as a Floridian, but everything should launch from Cape Canaveral. Listen, if you have never been to Cape Canaveral, go. It's a really nice base. It's flat in a good way because it's easy to launch things. It's close to the equator. It's just perfect for launching. Why would you do it anywhere else?
Michael.
Yeah.
Michael, what is flat in a bad way?
I'll tell you something. As a kid from South Florida, the Miami area, I could see when the space shuttle would go up, it was bright enough that I could see it from South Florida. And so that's, Cape Canaveral's really cool. You can see it from pretty much the entire state, a launch on a nice clear night, which we have. All right, the bonus. The bonus. Oh, the darn race. The darn race.
How many? Go ask Google or ABC, whatever they are. It's 7.
It's 7. I will not explain it to you here because
I don't know why it's 7.
Go to the QR code if you'd like the explanation. For those of you that answered less than 5, how?
Yeah.
For those of you that answered 5, that's what I thought first. But think about relativeness.
I thought it was 6.
No. You need more than that. You need 7. Go to the QR code. It'll explain it. All right, the fun part. So
Oh, no.
Okay. what we're doing is because I'm really happy that everybody put effort into the elemental name one. So we wanted to award the one that was the most creative out of those that didn't win the competition at all. So effectively, this is an honorable mention, and you will be getting, in the honor of the punch cards, a punch sticker. Which, if you stick it on your punch card, now you've covered the holes. So, the winner of the punch sticker is the JAXA Rejects.
What's the name?
And theirs was Bill Nye the Science Gynium. So, yes. Now, I want to say that of our 3 winners, they all had, let me make sure that I'm not, they all had clever names as well, but they win real prizes. So, not that that wasn't real. I'm sorry, that was real. Books. All right. All right. In third place, winning 2 of our totality books written by Jeffrey Bennett is, let me do it in the voice. Is mayonnaise a planet? And their name was Speck Whittingtonium. Speck Whittingtonium. So Dr. Speck, who spoke tonight, her husband is Alan Whittington. So it's a nice tribute to, and we saw their wedding photos. So, all right. Number 2, the second place, so they'll stop yapping, hopefully, is the Wondergrads. And they're winning tonight this beautiful Eclipse poster and a beautiful Eclipse tumbler. Second place, come on. Clap, clap, clap. So theirs, their element name was a little bit more pointed at yours truly because they did it, theirs was Cornelium. So, yes, that's, yeah. No, I'm not Andy Bernard. I am not Andy Bernard. All right, in first place, winning the, once again, this beautiful poster, and the 4 Lunar Orbiter prints is the Genius and the Idiot.
Wait. Who's who?
Wait, which is which?
I'm the genius, obviously.
Okay. And their thing was clever. It was just insert element name here. You know, I like to interpret what nobody in the physics realm put. I'm a little bit disappointed. Is we'll leave this as an exercise for the reader. Y'all missed out. All right. We had a fun time tonight. Thank you all for coming out. It was really great. Everybody be safe and have fun for the total solar eclipse on Monday. It's going to be amazing. We've already talked about the once-in-a-lifetime experience. Go out and have fun. We'll see you again on Wednesday, May 1st, right here at 7 p.m. Thank you again to our wait staff here at Blue Star and the Blue Star Brewery as a whole. We can't do this without you. And the Southwest Research Institute, UTSA, for their continued support. And thank you all for coming. Good night.